I really hate splitting up footage like that from one day to the next, but some of you did actually post very valid questions in the comments on the video yesterday. So if you haven't checked out the video from yesterday, that was the beginning of this case, and I highly recommend to watch that first. In the description you'll find the link to that, so go there and click it out if you haven't seen it yet. But the long story short is that by the time I got home, I thought I had everything figured out and I just needed to put it together in one form of video. But it turned out that the power setting was way off, and I needed to physically be here back in the lab to adjust the power setting when the NAND is being read. NAND is the memory component where the data is kept. This device had two NANDs, and each NAND had two banks inside, meaning that it consisted of two parts. So together it makes up data out of four parts. They need to be merged together into one to give us the data. So today I'll be adjusting the power setting to a point where the device can be corrected properly, and we are expecting to have all green map. Now this procedure is only needed in case if your flash drive or your memory card or any other type of flash memory device is not getting detected and software options had been attempted and had failed. So if you lost data on a flash drive like that customer did, you would definitely need these kind of services to get this information recovered. I left office reading the memory component at this setting here, 3 and 3 volts. That result gave us this on the chip 2, but that same result is giving us really bad reading on chip 1 part 2. So if we run read retry with the SanDisk option here, it's going to give us different read retry methods that could be applied in order to improve the quality of the read. But you guys can see that the screen is not really turning all green or not showing really great result overall, and pretty much everything is consistent. You know, you get anywhere from 500 to 600 red blocks, and you get about 600 to 700 green blocks. Currently it says the value 6 is the best, because the value 6 is going to give us 690 greens and 517 reds. But that's not good enough. That's definitely not good enough. So I'm going to run it once again, but I'm going to tweak the power a little bit and turn it down a notch. Usually I would set this up to like the mid-range, and then I would want to go somewhere around 2.3. So let's see what this gives us as far as the results go. Same thing there. Select SanDisk. This may look even worse. It definitely does look even worse. So this definitely looks even worse, but let's try to play with the fine-tuning of the power. Whoa, we just needed a little bit of power in here. You see this? So 2.449, basically 2.5 volt is going to give us this green map. The reading is now finished, and we got both of the chips reread, and as you can see the structure had improved significantly. It may need another pass to make it absolutely flawless, because right now if we run a single ECC correction, we still end up with a little bit of red areas. But if we try to read it, let's say with combine on the same setup, we may end up having a slightly different picture. And if the red blocks appear in different positions, combined, we'll only use the green map and basically merge two maps into one and make one perfect green area. So this is coming up to an end. Let's see, open. And now we have the fat tables. We couldn't see those before because of the bit errors, but now if we explore the root, I'm gonna obviously blur this out, but we will be able to see the directory. If there are any headers that are busted, again, that's because of bad sectors, and we'll need to reread to get a cleaner outcome. But that's pretty much what happens when we're dealing with problematic chips that don't like to be read on the first attempt. But this actually looks really good. Okay, all these are read because this has been probably worked with Mac, so indexing saves every file with like a little dot in front of it, so the headers always fail. But if we look at regular types of files, these are all green. It's actually pretty good turnout of events as it is. Like, just to get it perfect, obviously I'll have to reread it again, but we're on the right track, and this is gonna be a successful recovery once it's done. I got this package in the mail, and I think what's inside here is what I ordered a couple of weeks ago to modify my laminar flow bench. I'm gonna do like a video that will be made to show my work area inside of the laminar flow cabinet. But currently I have a HP workstation sitting in there simply so that I can hook up hard drives while I'm doing the work. And let's say I just finished a physical repair on the drive, I can hook it up to MRT and test it right away, or begin imaging right away. What's in here today, I think, is going to be a good addition to the laminar flow when I do the modification. I modified it a little bit by mounting, a monitor inside and setting up a computer, but with the laminar flow bench, the impellers that are built into the top, they push the air inside so it comes out facing me, and all of the air kind of gets pushed out from the box. So by having a workstation with dual fans sitting in there blowing air inside of the box is a little bit of counterproductive. Not that it creates a huge contradiction, but if the laminar flow is turned off, the computer does work non-stop anyways, so every time I have to sit down to do the case, I have to do a full sweep of the things inside, and I want to keep it as tidy as I can. So I think what's in here is going to help me in a big way. So I had an idea of having all four of them set up in an array that will allow pretty much so I will be designing a plate that will have all four of them lined up, because there are 4 of them total, but all 4 of them will be lined up, so the connectors are they're probably going to be spaced out in a line, not stacked above each other, but spaced up in 4 little sections, with one custom bracket made that will pretty much be able to mount them from the back, and all you see in the front of the laminar flow is going to be this one little plate that's got 4 of these slots out. The other end of these cables, they plug into either MRT or PC3000. So with that one end being plugged into the machine, this end is then going to be connected to this part here, like that. This plate gets mounted from the outside of the box, but because this has these brackets here, it can actually be secure and mounted properly to the front wall of the laminar flow. And if all 4 of them are lined up like that, I end up having this kind of connector right in the wall of my laminar flow bench. Because if I need to attach, let's say this is already mounted into the wall, and I need to attach a cable directly to my hard drive, all I have to do is plug this in, and the same type female to female cable for the power, and that gets connected directly to the drive. So the workstation is going to be sitting outside of the laminar flow bench, but it's going to have an interface that I can use inside of the bench without creating any interference with airflow.